A very warm welcome again. Still on the road to becoming masters of calculus. Okay, so on the last video we talked about we did a bit of revision on applying the rules, and then we touched on a very crucial concept, which is knowing the what is the the difference between these notations, right? To say what is the difference between this and then that. Okay, so remember that this one we said the this thing is the y value, right? Is the y value when our x is 2, and then we said here it is the gradient, right? You can say it's the gradient of a tangent, or is the gradient at a point, a gradient at a point where on that point the x coordinate is 2. Okay, so remember a point is always made up of x and y, right? So we are saying we know the gradient at that point, but we only know that x is 2. Okay, remember here it means x is 2, right? So we only know that at that point x is 2. We do not know y. However, at that point that will be the gradient. What do I mean? So let's remember, if I have g prime of 3 is equal to 5, it means if I have a graph at this point here, at that point where x is 3 and then I do not know y, at this point the gradient is equal to 3. So if I were to draw my straight line there, which is a tangent, if I were to draw a tangent here, that tangent would have a gradient of 3. Okay, so that tangent would no let's not make a mistake, would have a gradient of 5. Did you realize that? Would have a gradient. Remember, it says the gradient at 3 is 5, so the gradient of this tangent would be 5. That is passing through a point which is 3 is to something. We do not know the y value at that point, we only know the x value. Okay, so let's try to reiterate that. Okay, let's try to re-emphasize that. Okay, because now we're going to move to some crucial problems that you're gonna find in your exams, and then that require you to know that thoroughly. Okay, so let's know that if I were to tell you that at a certain point, right, at a certain point in the graph of or rather on the graph of grx, on a certain point on the graph of grx, the gradient is 10, then you should know that this statement here means g of x would be equal to what? To 10. This means the gradient is 10 at a certain point. Mind you, on that point I do not know what is x, I even don't know what is y, so that's why we just write it like this. However, if we write g prime of -3 is equals to 6, what does it mean? It means on a graph of g, right, I'm just using a parabola, but remember the graph of g can be any graph. Okay, it could be a cubic function, a straight line, or any graph. So I'm just using this as an example. So it means at this point here, this particular one means I know that the x value at that point is -3. I do not know the y value, but what I also know is that there is a tangent at that point. Okay, this is the tangent, and then that tangent has a gradient. Okay, that tangent has a gradient of 6. Okay, this is the gradient 6 at this point. Okay, so meaning at this point here, the line that will be passing that point will have a gradient of equal to 6, right? But it is actually supposed to be -6 because this is decreasing there. All right, but let's not waste any time. Let's look at a problem, right, and see how do we apply whatever we are saying there, right? Let's give you this one here. They say determine the equation of the tangent to f at that point where x is 2. Okay, so what are you given? You are given the equation of f. It says x squared. So x squared tells us that we are dealing with a parabola, isn't it? We're dealing with a parabola. So if I were to quickly have my Cartesian plane, I can say I have this and then I have that, right? So that parabola there, a is positive, so it definitely looks like something like this. It looks like this. Right, this is not the correct one, but I'm just assuming that it will be having this shape. Now at x is equal to 2, right, there is a certain point here, and on that point, what is the value of x? The value of x is 2. What is the value of y? We do not know, so I'm just gonna write it as f of 2 because I don't know the value of y. Okay, this is my f. So they say determine the equation of a tangent at that point. So it tells us that we got a tangent line, right? We have a tangent line that is passing through that point. This is the tangent line, and we want to know what is the gradient of that tangent. Okay, what is the gradient of that tangent? Well, a tangent is always a straight line. Can't we find the gradient of that tangent by saying y2 minus y1 all over x2 minus x1? Can't we find the gradient using that method of that tangent? And then after we get this gradient, we then say, okay, we know that since it's a straight line, y is equals to mx plus c. So we substitute the gradient, then we substitute a point and get the equation. Why can't we do that? Well, the problem with this method is that this equation here, my dear friends, this equation, it works if you are given 2 points on the tangent line, but at this case we only have 1 point on the tangent line. Do you know this coordinate, this point? No. Do you know this one? No. So we only know 1 point. So how do we get the gradient at only 1 point? That is the derivative. Okay, so remember, the derivative is the gradient at only 1 point. So your derivative, remember, the derivative of f means the gradient at any x value we want. Okay, so this is gonna help us to find the gradient at any x value we want. That is what is a derivative. So a derivative helps you to find the gradient at any x value that we want. So don't we know the x value there? We know the x value, so we're just gonna find the gradient of this and the derivative of this, and then we can get the gradient at 2. So how do we get the derivative of f? So I'm gonna write solution here, right? So first of all, we have to find the derivative of f by applying the rules. Already it's in a correct format of a x to the power n, right? So I'm just gonna apply the rules. Remember, here it's 1, so I'm gonna say 1 times the exponent, which is 2, and then I say x, and then I say 2 minus 1. What about this one? Remember, if we have the exponent as 1 on x, the gradient is just the number in front. So I'm just gonna say, which is the coefficient, I'm just gonna say plus 4. Then what is the gradient of a number, of a constant? It's 0. Okay, so it means the gradient of f would be equal to 2x plus what? Plus 4. Now that we have the gradient of f, where do we need the gradient? We need the gradient at x is equals to 2. So you just say the gradient at 2 will be equal to 2 into 2 plus 4. We just substitute 2 there. So 2 times 2 is 4. 4 plus 4 is what? 8. Therefore, the gradient at a point where x is 2, the gradient is 8. What does it mean? Right? Now that is a powerful statement we wrote there. Now we found the gradient. Instead of using this formula here, we just use the derivative to find the gradient. Okay, to find the gradient. So we therefore say, therefore at x is equal to 2, the gradient of our tangent line will be equal to 8. So it means the gradient of this tangent line is what? Is 8 at this point there. The gradient of the tangent line is what? It's 8. How does the gradient of the tangent line help us? Remember, the question said determine the equation of the tangent. Now remember, a tangent is a straight line. It has the equation y is equals to mx plus c. Okay, so now that we know already the gradient of our tangent, we're gonna say y is equals to 8x plus c, because 8 is the gradient of our tangent. What are we left with? Finding c. How do we get c? C, we substitute a point. Remember, right? We substitute a point. My name is Clayton. So C always reminds me that I have to substitute a point today. If I don't do that, it's like I've forgotten my name. And we don't want to do that, right? So we're going to substitute a point so that we get C. Now, this is the point here. We know that here at this point x is 2. But the question is, what is the value of y? We don't know the value of y. How do we get the value of y? We substitute 2 into the equation. Not here, because if you substitute 2 here, you are getting the gradient. Okay? If you substitute 2 here, you are getting the what? You are getting the gradient at x is equals to 2. So we need the y value, the corresponding y value to this. It is f of 2. So to get f of 2, right? To get f of 2, we are gonna substitute 2 into this equation so that we get the y value. So we say 2 squared plus 4 into 2 and then plus 3. So that would be 4 plus 8 plus 3. What is 4 plus 8? It's 12 plus 3 is 15. So it means f of 2 is what? Is 15. It means where I see f of 2, I can put 15. It means here, do you see f of 2? I can remove that and put what? And put 15. That is the corresponding y value. Remember, this is the y value, right? This is the y value when x is what? When x is 2. Alright, so that is what we substitute here. Now that we have x and then we have y as our 15 there. So therefore, where I see y, I'm going to put 15. Where I see x, what do I put? I'm going to put 2. Okay, so I will have 15 is equal to 16 plus c. Then I can say 15 minus 16 will be c. Then what is our c? Therefore, our c would be negative 1. So therefore, the equation of our tangent, okay, good people, the equation of our tangent will be as follows. So you say, therefore, the equation of our tangent will be, right, will be y is equals to 8x minus 1, because c is minus 1. Okay, so that is the equation of this tangent here. So the equation of that tangent there, you can write it as y is equal to 8x minus 1. It's a straight line. That is why we get an equation like this. Okay, I hope that was very, very clear. All right, let's look at another one. Now here we have, let me see if it's the correct one. No, let's check this one first. No, let's go back to this one. So this is the one that we have, right? Okay, so it says that you are given f at x is equals to negative x squared plus 3x, and then g of x is that, ne? I feel like maybe this is a bit of an extreme question for now. Okay, excuse me, good people, let me remove that and say, let's say given, right, let's use a different color, given that f of x is equal to 3x squared minus 6x, right? Determine, right, okay, let's write it nicely. Determine the equation, the equation of a tangent to f at x is equals to 5. Okay, now you can pause the video, give it a shot, and then we'll look at it afterwards, right? So now we are given that this is our f at x, that is our graph. So we can just say that is our graph there. Now on our graph, we want the equation of a tangent to that graph. at x is equals to 5. Let's just say our x is equals to 5 is at this point here, right? So this is our x is equals to 5. We do not know the y value for that. We can just write it as f of 5. Okay, so we have a straight line which is a tangent that is passing through that point and touching that graph at only one point, that point only. So we want to know what is the equation of this tangent line. Okay, so remember, since it's a straight line, it's going to have an equation of y is equals to mx plus c. So we firstly need to know what is the gradient of the tangent. Then after that, we substitute this point and get the equation of the tangent. So first of all, we need the gradient at 5, which is going to be the gradient of the tangent. So we need to find the derivative because it's only one point. So we're going to say the derivative of f would be equal to 3 times 2 is what? Is 6, and then 2 minus 1 is 1. Now I'm being a bit fast, isn't it? And then here the exponent is 1, so I'm just going to say, I just take the coefficient, which is -6. That is, I've applied the rules then. So I want the gradient at 5, so I'm going to say the derivative at 5 is equal to 6 into 5 minus 6. So what is 6 into 5? That is 30 minus 6. So the answer should be 24, right? The answer should be 24. So it means the derivative at 5 is 24. Therefore, the gradient of our tangent line is what? Is 24. Now that we have the gradient, we then say, therefore, y will be equal to 24x plus c, because that was the gradient of the tangent line, isn't it? This one there, that was the gradient of the tangent line. It's 24. Now to get our point, we need to substitute this point there, right? We need the x and the y, but we do not know y, we only know x, right? So to get y, I'm going to say f of 5 is equal to, I substitute into the original equation, and then I say 3 into 5 all squared minus 6 into 5. Then I'm going to get 3 into 25 minus 30 there, right? So what would be the answer? We would say, okay, that is 75, if I'm not mistaken, minus 30, which is going to give us 45. Okay, so therefore I know that now my f of 5 is 45, which means our y is 45. So we put 45 is equals to 24, the x will be 5, right? And then plus c. So good people, we're gonna have 45 is equals to 24 times 5. Okay, 20 times 5 is 100, 4 times 5 is 20, so here we're gonna have 120 and then plus c, right? Then we just say c would be 45 minus 120. Okay, so what is 45 minus 120? 40 minus 120 is negative 80, so it means this would be negative is it negative 75? Yeah, it should be negative 75. Yes, so therefore c is equals to negative 75. Okay, so we got our equation there. Therefore the equation of that tangent would then be y. So we say therefore the equation of our tangent will be y is equal to x is gradient is 24, x, c is negative 75. Okay, so that is it there, right? So now that you know this, let's then continue to some bit of more complex examples, right? The one I was talking about this. Now before we can do this, right, I need you to know that from analytical geometry, remember we learned that if this is line AB, right, AB, and then this is line CD, okay, line CD, okay, if these two lines are parallel, right, if those two lines are parallel, okay, it means that therefore it will mean that the gradient of AB should be equal to the gradient of CD. So lines that are parallel have the same gradient. Okay, so if I have, let's say this is KG, and then let's say this is CF, right, if they are parallel, it means the gradient of kg would be equal to the gradient of cf. Okay, that's just what we must remember there. So now that we have remembered that, we are given f of x is equals to negative x squared plus 3x. Okay, so you know that your f of x is negative x squared plus 3x, and then you're also given that g of x is 2x squared minus 3x. Now they say determine the value of x, right? Determine the value of x for which the tangent to f, right? For which the tangent to f is parallel to the tangent of g. The tangent of f should be parallel to the tangent of g. Interesting. Seems like it's a bit confusing, isn't it? No, this is what you need to remember. Okay, let's just say that this is f here. Let's just say this is f. Let's just say the point is this one, and then at that point we have a tangent line. Let's just say we have our tangent line. All right, so they are saying that, and then let's say we have g, right? Okay, I'm just gonna represent g in yellow. Let's just say this is g there, right? This is g, and then we got x here, we got a point there, and then at that point we have a tangent line to g, right? Sorry, let me just maybe write it like this, right? So they are saying the tangent to g, right? This is g, and then this is f, so this is g, and then that is f. The tangent to f, which is this one, or they are saying is parallel to the tangent of g. So these two lines here, they are what? They are parallel. What do we know about parallel lines? It means the gradient of this line here must be the same as the gradient of that line, so that we can say they are parallel. So they want to know at which x value will that occur. Okay, at which x value will that occur? Well, so now, like I said, this is a bit complex, isn't it? But worry not, good people, we are still together. So now let's start first by saying, if I have f of x, how do I get the gradient of the tangent to f? So I'm gonna find the derivative of f. If I find the derivative of f, I'm gonna have, remember, negative 1 times 2, that will be negative 2, and then you have x, because 2 minus 1 is 1, and then here I'm just gonna say plus 3, right? I'm just applying the rules. Okay, so this is the derivative of f. Remember, what does this derivative of f give me? It gives me the gradient to f. Do you still remember that? If we have the derivative of f, if we substitute a certain x value, which is this point here, the x value there, we get the gradient of the tangent. Remember, we get the gradient of the what? Of the tangent. So if I substitute a certain x value, I'm gonna get the gradient of a tangent to g, meaning the gradient of this line. So I do not know what is this x value here. I don't know it. I just don't know it, and then I don't even know the y value. I'm just gonna say, okay, I don't know it, so I'm not gonna substitute anything. Let's look at for g of x. How do we get the gradient of this yellow tangent here? We're gonna say derivative of g is equal to 2 times 2, right, which is 4, and then you say 2 minus 1, then here you're gonna say minus 3. I just apply the rules. Now, good people, if I substitute a certain x value here, I'm gonna get the gradient. I'm gonna get the gradient at the gradient of a tangent to g. Now, right, the question said, what is the value of x, so that the tangent to f and the tangent of g to g, they are parallel. We know that the gradients must be the same, so that those things are parallel. So remember, since this here gives us the gradient, and also this one here gives us the gradient of what? the gradient of a tangent to G, and then here this one gives us what? The gradient of a tangent to F, right? Those gradients must be equal so that those lines have the same gradient. So it tells me that negative 2x plus 3 must be equal to 4x minus 3. The gradient of a tangent to G must be equal to the gradient of the tangent to F so that those lines are parallel to each other. Okay, so then we solve, right? Then we can say we have negative 2x and then minus 4x is equal to negative 3 minus 3. So I'm gonna have negative 6x is equal to negative 6. Then you divide by negative 6, you divide by negative 6, therefore your x is 1. Now check what happens when you substitute x as 1. For this tangent line here, it means x is 1, and then it means x is 1, right? What would be the gradient of our tangent? The gradient would be negative 2 into 1 plus 3, so the gradient would be negative 2 plus 3, which is 1. What about in here? If I were to substitute x as 1, I'm gonna get 4 into 1 and then minus 3, which is gonna be 1. So do you see that the gradient of a tangent to G will be the same as the gradient of the tangent to F, which is both, they will have a gradient of 1. So that is only possible at an x value which is equal to 1. Okay, so it means we should perhaps draw our graph correctly there. It means our sketch is actually not like this, because if the sketch was like this, it means we are having the gradient at different x values, right, which is not correct. Okay, so let me show you quickly the actual sketch of that. This is the actual sketch of that. So as you can see here, right, we have the graph of what? This is the graph of F here, right? That is the graph of F, and then we have the graph of G here. Now the tangent to G, right, is here. This is the tangent to G, right? And then here it is the tangent to F. So these two lines, since they are parallel, it means they both have the same gradient, and we calculated that gradient. The gradient is 1 at x is equals to 1. So the gradient is 1 and then the gradient is 1, and all of that is happening where the x value is the same. The x value is equal to 1. Okay, so it means this coordinate here is 1 is to a certain y value, and then this coordinate is 1 is to a certain y value. Okay, so at that x is equals to 1, both tangents have the same gradient, meaning both tangents have are parallel to each other. Okay, so that is what that question was just asking you about, right? To say which value of x is the tangent to F, right, parallel to the tangent of G. It is at x is equals to 1. The tangent to F will be parallel to the tangent of G. I hope that makes sense. Then it says determine the point on F which has a gradient of negative 9. So we know that this is F, right? We want to know which point on F has a gradient equal to what? To negative 9. So what are we given? We are given that the gradient is equal to negative 9. So we want to know at which point is that. So I'm just going to write it like this to say, remember, this is the gradient of at any point. So the gradient is negative 9. We want to know where is which x value is that occurring, whereby we get the gradient as negative 9. Please, good people, just remember that this equation gives you the gradient. This equation gives you the equation. It's an equation to get the gradient at any point. That is what you call a derivative. It's a gradient at any point. Okay, so to get the answer to that, what are we gonna do? So we are gonna say, okay, we know that the derivative of f, what was the derivative of f, is negative 2x plus 3, right? So you're gonna say negative 2x plus 3 is equal to negative 9. Okay, so when you take 3 to that side, you have negative 2x is equals to negative 9 minus 3, which is negative 2x is equals to negative 12. So when you divide by negative 2 both sides, you get x is equal to 6. So at x is equal to 6, you can check. So it means 6 would be somewhere maybe somewhere here, right? Maybe we can say this is f, right? So 6 can be somewhere here, maybe, right? Let's remove everything else so that this does not confuse us, right? So at x is equal to 6, somewhere maybe here, right? X is 6, we do not know the y value, right? X is 6, we don't know the y value. However, the tangent at that point, right? The tangent at that point, it has a gradient, right? It has a gradient that is equal to negative 9. The tangent at that point is a gradient that is equal to 9. That is what this means. Okay, the gradient is negative 9. At a certain point, we do not know what is that point. So we know that at that point x is 6. Do they want the actual point? Yes, they say determine the point on f which has a gradient of negative 9. So the point that has a gradient of negative 9, we know that the x value of the point is 6. So to get the y value, we're just going to substitute 6 into the equation of f. So what is the equation of f? Remember, f at x is equal to, let's just check, f at x is equal to negative x squared plus 3, right? It's equal to negative x squared plus 3. So when x is 6, the y value will be negative 6, or will be 6 all squared, right? Negative into 6 all squared plus 3, which is negative 36 minus 3, which is negative 39. So it tells you that at that point the y value is negative 39. So it is actually not this point here, but it's a point that would be somewhere maybe there. Okay, so 6 will be, we would have x as 6 and then y as negative 39, and then at that point there our tangent line has a gradient that is equal to negative 9. Okay, I hope that was helpful. I think I took a bit of an extreme question here, right? That required a higher level of thinking. Trust me, on our next one, I'm gonna tone it down. Just say, Clayton, tone it down. We're gonna tone it down and maybe check a bit of more understanding questions that does not demand a lot. Okay, so see you on the next one. Stay tuned.